Can we see okay? Yeah? Now, do you remember the situation yesterday where we said, oh, we have no idea what the function is doing? Do you remember what situation that is? Yeah, what's 0 and 0? First and second derivative, okay? But the good news is there is a way out of this problem by looking at the third derivative. And if the third derivative doesn't work, then we look at the fourth derivative. So don't worry, there's a way out of this 0, 0 problem. And I'll give you an example of how it works. So what was the example we did yesterday? Yeah. Let's say we had y equals x power 4, and we want to know what is the function doing when x is 0. Well, we at least know what the y is. What's the y? It's 0. So at least we know that the function passes through 0, 0, right? But we don't know anything about the shape yet. So let's have a look at what we can do. So the first derivative would be 4x cubed, yeah? And when you make x equal to 0, this becomes 0. Oh, so this makes us think that perhaps we have a turning point. So let's look at the second derivative. Maybe it's a max, maybe it's a min. This would be 12x squared. And x is equal to 0. We get 0 again. Oh, so we don't know if it's a max or a min or a saddle point. We don't know. We don't know what the shape is. We don't know if it's concave. We don't know if it's convex. We don't know. But in these situations, what we can do is look at the third derivative. In this case here, this will be 24x. And x, when we put in 0, we get 0 again. So we have to go one more. What are we on now? The fourth derivative. We usually use Roman numerals up here, so that's the fourth derivative. And what do we get? 24. Ah, so finally, we don't get a 0. We get a positive number here. But I haven't said exactly what the positive number here means. Now, I find that the easiest way to explain this is with a flow chart, which I've actually put into your workbooks here. So if you can just open this flow chart here, we'll explain how to use this. Do you all have this flow chart open? Yes? Yeah. Okay, so let's look at the chart. We go to the top. Start with a function and a point. So for this example, what was my function? What was it? x4. And my point? 0. Fine, okay. So, step 1, differentiate and evaluate. That means get the derivative and then put the x value in. So I differentiate and evaluate, and I either get a positive, a negative, or a 0. So, what happened here when I differentiated and evaluated? I got 0. So, which way am I moving on my flow chart? Yeah, down. Yeah, down the chart. Can you see? Right. Differentiate and evaluate. Do I get a positive, a negative, or 0? So here, yeah, I got a 0. So what am I doing? Going down again. Differentiate and evaluate. What did I get here? Positive, negative, or 0? I got 0. Now you see what happens with the flow chart? I go back up to a step earlier. Differentiate and evaluate. What did I get lastly? Positive. So what do I have? Local min. And this is satisfying because if you plot this, you get this graph, which indeed is a local min. Now this is not going to be easy to remember, okay? But it's not as complicated as you think, because a lot of what's in this flow chart we did yesterday. So for example, let's say we differentiate and evaluate and get 0, and then we differentiate and evaluate and get positive. That means we have a min. We did that yesterday, didn't we? This was the first derivative is 0, and the second derivative is positive, it means we have a min. And if the first derivative is 0 and the second is negative, we can see on the flowchart we're at where? First derivative is 0, second derivative is negative. Local max. And also, if you go left at the beginning, the first derivative is positive. What does that tell us about the graph? If the first derivative is positive, what's it doing? It's rising, isn't it? And if the second derivative is positive, it's convex. Remember we did that picture yesterday of the 9 different situations? So everything on this flowchart is from yesterday's class, except for one part of the flowchart. What is new for today? The bottom one, isn't it? Where it says rising and saddle and falling and saddle. You see that? So let's do another example, maybe a little bit smaller example, just to practice this flowchart more. So we'll just finish this answer off by... It's actually better than a local min. It's actually... this one is actually a global min. Now in this example, maybe you didn't have to do all this work because x power 4 is kind of like what other function? Similar to what other function? But, yeah, it's like x squared, isn't it? Because what does a power 4 do? Makes it positive. So this kind of has to be the minimum because you can't have negative, right? But let's look at a different example. Can I scroll down? Yeah. So let's try x cubed again, and let's do the same thing. We want to know what is happening when x is 0. Okay, first derivative, 3x squared, x is 0, we get 0. So we think we have a turning point. Second derivative is 6x, x is 0. So when x, sorry, I should write x is 0, we get 0. So this means we don't know what we have. Third derivative is 6, which is positive, and that makes this one a rising saddle. So it should look like this. Rising saddle. Now, if the third derivative was 0 instead of 6, what do I need to calculate? The fourth derivative. So do you see, I wonder if you can see what's happening here. The third derivative tells us if we have a rising or falling saddle point. What does the fourth derivative tell us? If we have a min or a max. What does the fifth derivative tell us? Right, if it's saddle, sixth derivative? No, min or max. Do you see how the loop at the end means you're switching between the two situations? Exactly, yeah. Very good. So, saddle, min max, saddle, min max. So yeah, you figured out that if it is even, it's telling you if you have a min or a max, whereas if it's odd, it's telling you if you have a rising or falling saddle point. And what's nice about this flowchart and this rule is that it works. It must work. You cannot keep getting 0. Eventually, you'll have to not get 0. So you have to stop at some point. I mean, the only exception to that is if you have the function y equals 0. Otherwise, you have to stop at some point. We'll do some examples from the book now. I'll let you write this one down. So this one is rising saddle. And you remember why we call it a saddle? Oh, come on, you forgot my little story? Why do we call it a saddle point? Like a horse saddle, yeah. Yeah. Okay. Right, once you write that down, we'll have a look at some examples here. Now, usually the way this comes up in the exam, it's not a very common question in the exam. I'd say it comes up about 20% of the time. It usually comes up in the form of, they ask you to find turning points, they ask you what the nature is, and then they ask you to do a quick sketch. So it's good to know what shape you have so you can sketch it. Okay? Can I scroll down? Yeah. Right, let's have a look at an example here. I want all the turning points for this guy. Yeah. And I want, well, no, actually, I don't need to know the turning points just yet. I just want to know what is the graph doing when x is 7. What type of shape do we have? That's what I'm looking for here. Okay. So before I start differentiating, I think it would be nice to at least know what the y is. So could you sub the 7 into this, please, and tell me what you get for y? Yeah? Got your calculator? Oh, go on. What? Okay.
Yeah.
Minus again?
16,000.
Are you sure? Minus 16,000 and 40. 16440 like this? Yeah. No? 16, yeah. Minus 16440. Yeah? Okay. So we at least know that it's down quite far, but let's see what shape it is. Okay, so first derivative. That is for 16 x cubed minus 84, nope, that's not it, minus 168 x squared plus 588. We make x equal to 0, and what I really care about is if it's positive, negative, or 0. I don't really care too much about the number, just if it's positive, negative, 0.
I think it's 252. X.
It's also positive, is it?
No, minus 252. It's not 168.
Oh, sorry. Thank you. This is wrong?
252.
Oh, times 3. Sorry. 252. Thank you. So what do we get when we sub in the 7? We get a minus. Okay, good. Good. So, do we have enough info or do we need to keep going? Let's see. Differentiate and evaluate. What did I get? A negative. Negative means I either have something which is fallen and convex, or fallen and concave, or fallen and inflection. So I need another derivative to decide which of the 3 I'm at. One more derivative here. What's that? 48 x squared minus 504 x. And again, we put x equal to 7. This will probably be positive, negative, or 0. What do we get here?
Negative.
It's negative again. Alright, so if the first derivative is negative, what's the graph doing? Falling. And if the second derivative is negative, that means we have concave. So it's falling and concave. So the graph looks like this. At the point 7 and minus 16,000, it's going falling and concave. So that would mean it's looking something like this here. So we have a picture of the shape at this point. Okay. Let's have a look at another example now. Okay, can I do another example? Yep. Okay, so this time I'm asking for the stationary points, the turning points. Y equals log x power 8 plus x squared minus 8x minus 5. Right, well, we know how to get the turning points. dy dx equals, should bring the 8 down, that's 8 over x plus 2x minus 8, and that should equal 0. We did lots of these yesterday. What's the next step? Multiply by x, isn't it? So that's 8 plus 2x squared minus 8x equals 0. That's x squared minus 4x plus 4 equals 0. That's x minus 2 squared equals 0. So y equals log x 8 plus x squared minus 8x minus 5. It has the stationary point at 2. Now I'll have to sub the 2 in to get the y value. I think it'll be minus 11.5, but maybe someone could check that. If you sub the 2 back into this, you get it. Now we're not finished because we don't know what type of turning point we have. Okay, good. Yeah. Okay. Right. So let's get the derivative again. And we did this one yesterday too. Derivative of 8 over x is minus 8 over x squared plus 2. Now, what happens if we put in 2? What do we get? Let's see. Minus 8 over 4 plus 2, 0. So we know what happens now. What do we need to do? We look at the third derivative. Okay, so that'll be 16 over x cubed. Oh, now the 2's gone. We can put in x is 2. So that's 6. Well, it doesn't really matter what number it is. It's a positive for sure. So a positive third derivative tells me I have what? Rising saddle, isn't it? Yeah, so the graph looks like this. There's 2. There's minus 11.5. And rising saddle is going to mean it's like something like this. Yeah? That's what the graph is doing around about here. Yeah, there's one way to find out for sure. Now, there is another way to do this question that doesn't involve using the third derivative to figure out the shape. Can anyone think of another way to figure out the shape if you didn't want to use the third derivative? So, imagine in the exam you got to this step and the second derivative is 0, and so you don't know what the shape is, and you can't quite remember how the third derivative works. Is there anything else you could do at this step? Any other ideas? If you want to know the shape. Oh no, that's too advanced. But you're right. But I need something more simple than this. A very simple thing you can do. Childlike almost. Maybe it's so simple you can't think of it. Too simple. Substitute values, correct. If you substitute a few values in near 2, you can make a sketch. So if you put in like 2.1, 2.2, 1.9, 1.8, you could get a little sketch, and then you could judge from the sketch what's happening, right? That's acceptable in the exam, but that's longer to do than simply getting the third derivative. So this is your choice, you see, and this is quite common in maths. You can have a technique which is quicker but requires more memory, or a technique which is slower but needs more time in the exam. And this is quite common in the maths paper, that you have these two strategies. an easier way to remember and do, but takes longer, or the quicker way, but you need to remember more for the exam. So which you choose is personal preference. Okay, some people will be thinking, oh, I want to do it as quickly as possible, I'll just remember about the third derivative, whereas some people will be thinking, I'll get confused in the exam and I'll just draw it. Okay? Which one you pick, that, like I said, personal preference. So to make sure that this is working, let's sketch it. What was the function here? Y equals log x power 8 like this. Now, let's see. Now, what was it? X is 2, was it? 2 and minus 11. So, I think we'd all agree that is definitely a turning point. It's level. And it's a saddle point, because on the left here it is concave, and on the right here it's convex. So, it worked. We got the correct shape at this point. So this is a very powerful method for getting the shape of the function. Okay. Let us do one more. What I actually really want to do is I want to do the one that was in the exam paper recently. So if you want to open up Moodle, let's open up Moodle. I can't remember which year it was, but it was pretty recent. There was a question with, I think it had an x power 4, and they asked you to get the turning point and to do a rough sketch of what's happening. So let's have a look at that. Has anybody seen use of the third derivative before? Those students who have seen calculus before. Have you seen using the third derivative?
The teacher showed us once, but
just once.
Yeah,
okay.
that's it.
Second was the most. Yeah, that's common. Yeah. Oh, slow. Right. Okay. Moodle. It was a part 1 exam. I remember that much. So let's have a look. And maybe it wasn't last year, maybe it was the year before. So let's have a look. You don't have your timetable yet for the exams, do you? A little bit too early? What exams? Your next exams. The end of semester 1 exams. Yeah. Just asking if you got your timetable yet.
But this is what we do. This is what we do.
Did you get the timetable? No, okay. Right, let's see. Not this one. Maybe one of you guys could look at the 2017-2018 papers and look to see if there's any question, please, about the nature of turning points. Well, I'll look at 2016-2017. No, not that one. Maybe it was the year after it. No, I think it's, you know what, I think it's the next year. I don't think it's this one. I think it's maybe 15-16. Oh wait, no, maybe. I think I will do this one, but but it's not quite the one I wanted, but it's a good one. And then maybe I'll just check the next year. No, not 15, 16. Shapers. Is anybody looking at 17, 18 to see? Aziz, are you looking at 17, 18, or are you just talking Arabic?
I'm looking for paragraph like this.
No. Can't quite find it. Maybe it was. Maybe I just dreamt it. I don't know. Ah. Typical. It would be the one I skipped, wouldn't it? I can't find it. I'll just do the one I got earlier. It's not exactly what I wanted, but it'll do. Oh wait a minute. Oh no, here we are. Perfect. Oh yeah, of course it was last year's one, the one I skipped. Right, okay. Close. Oh, I thought it was oh, it is a power 4. Good. It's exactly what I was picturing. Okay. Now, this is in section B, which means it's an optional question. You have to choose 4 questions from section B. So some students will like choosing this question, some students won't. But I want you to see that you should really think about doing this one, because there's not a lot of work to do for the marks. Like, how many marks are we looking at here? 5, 6, 7, 8, 9, 10, 11. For that much, I wonder if the rest is also... Yeah, we haven't done the last part, which is integration, so we'll just do this part here. Okay. For 2 marks, I think we can all agree that this first part is pretty easy. We just want the derivative. So let's copy that down. Y equals 24x cubed minus 18x power 4 plus 8. dy dx equals 72x squared minus 72x cubed. Is that right? 2 marks. Fine, yeah. A. B. Show that there are stationary points when x equals 0 and x equals 1. Stationary points is another name for turning points. And how do we get turning points? By making the dy dx equal to 0. So if I make this equal to 0, I can divide by 72. And what's in common here? X squared. And here I have 1 minus x equals 0. So this guy tells me x equals 0. Or, and this guy tells me...
X minus 1. 1 equals to 1.
Yeah. And isn't that what they just said? Show that 0 and 1 are stationary points. How many marks do you think? Well, so far we got 2 from this. And how many for this one, do you think? 2 again. So 2 marks, quick and quick. Okay. Can we go down to part C? Yep. Part C now. Now, part C, 5 marks. Now we're getting to the meat. Confirm that there is a point of inflection at 0 and figure out if you have a max or a min at 1. Okay, well, doesn't matter. What's the next step anyways? Second derivative. So 72x squared becomes 144x. Yes? Minus, and then 216x squared. If you sub in x equals 1, then you get a negative number for sure, right? So therefore, what type of point is x equal 1 if the second derivative is negative? Yeah, so what do we have? Maximum, isn't it? Local maximum. Now we're not finished, we still have to sub in 0. So what do I get if I put in x equals 0? I get 0. So what do I need to do next? Yeah, well, it will hopefully just one more time. Next derivative? 144 minus 432x. And when I put x as 0, I get a positive. So therefore, when x is 0, what type of point do I have? If it's positive third derivative, rising saddle. Okay, and there you go. 5 marks for that one. You see, this is why, if you can remember how these things work, you can get very quickly, what have we got here? 9% of the exam done. 9% of the exam. That's nearly a full grade. You know, that'll take you from a C to a B or a B to an A. Okay. And lastly, D, you want to sketch. And before we do the sketch, we better figure out what those y values are. So when x is 0, what's the y? That will be obviously 8. And when x is 1, what's the y? That'll be 24 minus 18 is 6. 14, is it? Not done? Really? A class full of students with calculators, yeah. Is it 14? Yeah. Yes?
Finding the what?
One sec.
Oh,
Is that okay? Right, let's make the sketch. So, there's x, there's y, 0, 8 I'll put here. Yep, and then 114. So, sorry, 0, 8 I'll put here, and 114 I'll put here. They're the 2 points. The first one, when x is 1, we have a max. So it has to be kind of a shape like this. Yeah? And the second one, when x is 0, we have a rising saddle. So I need to draw a rising saddle that goes into a max. Is there any more turning points? No, because we would have found them. So this guy must continue down forever, and this one must continue down forever. So it goes up, levels out to saddle, and then rises to concave and comes back down. How many marks? 2. So that's so what you're looking at on the screen is 11% of the exam, or 11 marks. I think it's a 100-mark exam. It didn't seem like too much to be doing for 11 marks. And to confirm our answer, we'll graph it. So what was it? 24 x cubed? Yeah. Yeah. Plus 8. Just that? There we go. Rising, levels off, and then rises again. So rising saddle. And then here, a concave, local, actually global max. So I know it's not beautiful, but it does match up pretty well with what I have here. Yeah?
Oh.
What?
It's the same.
Okay. You get it? Okay, good. Good. And then the other paper, this one here, again, you can see how generous the marks are. The curve C has, can you all see that? This cubic. Find the stationary points. For 6 marks. Determine if they're max or min. For 4 marks. So for 10 marks, they want the stationary points and whether they're max or min. Now, let's see how quickly we can do that. Right, so what's the derivative here? Let's just copy it down. Y equals x cubed plus x squared minus x plus 2. I'm going to get out my stopwatch and let's see how quickly we can do this, alright? By the way, this is my first smartphone. Do you know that? I bought it like 2 weeks ago. Yeah. You can do a lot of things on smartphones, I'm discovering, yeah? Right, okay. Start. Alright, so, derivative, that's 3x squared plus 2x minus 1 equals 0. Does this have nice factors? Let's hope so. Maybe 3x, x, 1, 1, plus here minus here. Is that right? 3, yeah, that looks right, doesn't it? So x equals a third or x equals minus 1. But which is a max and which is a min? Second derivative equals 6x plus 2. So if you put in 1/3, I'll get 6 over 3 is 2, 2 plus 2 is 4, it's a positive, and I put in minus 1, I'll get a negative. So that means the value at 1/3 is min, and the value at minus 1 is max. Let's sub in minus 1, so minus 1, they cancel, that's a 3, and let's sub in a third, that's a 27 plus a ninth minus a third plus 2. So what's that? I don't have a calculator. Come on, we're wasting precious seconds here. What is it? Come on. Come on, come on, come on. 49 over 27. Okay, stop. Right, 1 minute 36 seconds and we have 10%. Yeah? I know, isn't it amazing? Yeah, seriously, 10 marks is on the screen right now in less than 2 minutes. Okay, so I like the calculus question in the exam because you can very quickly get a lot of marks and this frees up time for the other questions that you might have trouble with. Okay, so it's a good question in the exam. We can't do part, and for 3 marks a sketch. Nice. So let's can I resume? Yeah, resuming. So we want a quick sketch here. X, y, minus 1 and 3 would be here. And 1/3 and 49 over 27 would be about here. What is this one doing? It's a max, and this one here? It's a min, isn't it? So the shape must look like this. Up to a max, down to a min, and off we go. Okay, let me stop. Right. 2 minutes, 12 seconds, and now we have 13 marks. So this last part here is only 2 marks. And again, we haven't done it yet, but it'll only take a few seconds. So you can get 15, a full section B question done in 3 minutes, I would say. Okay. But for you to be able to do it so quickly, you need to have all this in your mind, all the rules. You know. So, like I said, it's personal preference. Okay. Right. I'll let you try some of these for a few minutes. Let me tell you which ones. So, 1 AB, 2 FG, and 3. There you go. 1, 2, 3, 4, 5 questions. Number 3 is very difficult. I would say if you got number 3 done, you've completely understood this lesson. Number 1 and 2 is a more exam appropriate. Okay. All right. I'll let you try these for a few minutes. No, just give me a minute to have some coffee, and then you can come up. When maths teachers give their students questions to do, it's so that they can have a little break sometimes,